Okay, welcome everyone to today's seminar. It's a pleasure to introduce today's speaker, John Aycokc. He is Associate Professor for Computer Science at the University of Calgary in Canada, and there he is also a Director of the Computational Media Design Program. And his research interests primarily are in computer security, but he also looks at many other things like arts, ethics, programming languages, and of course game studies. And one thing he's particularly interested in is looking at how the early designs of computers and programming languages that were much more constrained given the available technology kind of shaped what game designers actually could do. And so today's talk is titled Retrogame Archeology. So welcome, John.
Good afternoon, and thank you for the opportunity to speak here. So what I'd like to do today is I'd like to tell you a story. This is my first computer. This is a Commodore PET 2001-8. And what the 8 meant was 8K of memory. Now, what might not be obvious by this is that this case was actually made of sheet metal. This thing weighed a ton. And to the extent that it opened, when you took off the screws, it opened like a clamshell. And it had a prop rod like you would find in car hoods so that the thing didn't come crashing down on your head when you opened it up. And I'm not telling you about this, about my first computer, because I'm a narcissist. I mean, don't get me wrong, I am a narcissist, but that's not why I'm telling you about this. So the Commodore PET was eventually supplanted by an Apple II, and this was my first game console at home. This is a Mattel Intellivision. And I picked one up a couple of years ago secondhand, and it rightly ranks on the worst game controllers of all time. So I don't know if you can tell the little bumps here on the side. That's what all the games mapped the jump function to. And so your hand would be cramping up after about 5 minutes. It was awesome. So at this point, you can probably guess my age to a fair degree of accuracy. And you could also say that I've been involved with retro games for some time. Of course, we didn't call them that back then. And so when I went to study computer science in university, we got to use these. Now, if you're unfamiliar with these, this is not a computer. So this is what's referred to as a dumb terminal, and it is an interface to a big computer, or what was then a big computer, which is located in some far-off room. And my point is this. These were very constrained systems and very constrained development environments. And now when I go into our labs, our computer science labs, I see our students working in an environment that looks much more like this. Now, I'm exaggerating, but only a little. They have their labs and they have their dual monitors and they'll have their laptops open beside them with access to all the world's knowledge. And then, for some reason, I've never quite been able to figure out, they have their cell phones out too, because obviously that wasn't enough. And even in our most low-level course where students work in the most constrained environment, they use these things. So I apologize, I would have brought one with me to show you, but airport security. God forbid I tried to bring a clock with me. So this is a Raspberry Pi. It fits in the palm of your hand. And even in its most minimal configuration, this has 512 megabytes of memory. Now, if you're playing along in the home version, what that means is that the gap between this thing in the palm of my hand and my first computer, this thing has over 65,000 times more memory than my first computer. Now, you might think that, okay, this sounds like a curmudgeon saying, get off my lawn, you young whippersnappers. But you know what? Something has been lost here. And to explain what's been lost, I'd like to turn to the composer Stravinsky. No, actually, I'm just kidding. That sounds too pretentious and academic. I want to turn to the guy who made this, Halo 2600. It's a version of Halo that ran on the Atari 2600. The guy who made this, Ed Fries, was a VP at Microsoft for Xbox development. So this is the title screen. This is what it looked like when you were playing it. There's Master Chief over there. This is what it looks like when you're about to get your ass shot off, because it turns out it's really hard to play the game and actually do a screen capture at the same time. So what Fries argued is that there is this connection between constraint and creativity, and this is really what Stravinsky was saying, and it's present in all these creative fields. In fact, just last week I was reading a book on architecture, and they said exactly the same thing. And what it comes down to is this, that really necessity is the mother of invention. So when I say constraints, what do I mean here? Well, it turns out that my first computer, the Commodore PET, was positively luxurious compared to the amount of capacity that the Atari 2600 had. Not to scale, by the way. And there's a great book by Montfort and Bagos called Racing the Beam. And it's very approachable, so even if you're not a computer scientist, this is actually a fun book to read, talking about how people built games for this incredibly, incredibly constrained device. So, okay, there's no pre-reading. So if you haven't read the book, let me just sort of condense it all into 140 characters or less. So imagine, if you will, that this is your television screen. And the way that the television screen produces images is that there is an electron beam sweeping across and tracing out imagery as it goes past. And then it will go back to the left-hand side. And then it'll go back to the right-hand side, tracing out the next line of imagery. And it keeps repeating this time and time again. I'm not going to go through all of them. Until it gets down to the bottom of the screen, and having run out of lines, it goes back up to the top. And as a side effect of doing so, 60 times a second, so a fairly fast process, the side effect of doing so, you see an image on the screen. Now, as a computer programmer, then or now for that matter, if you were to want to create an image on screen, essentially what you would do is you would say, okay, here's my image. You would put it in the computer's memory, and the hardware would magically take care of making this appear on screen. But not for the 2600. Memory was expensive. And so instead, what you had is, so this red dot is the electron beam. What you had to do as a programmer is you had to have blinders on, and you were responsible for rendering each and every line, and you had to do it before the electron beam got to that point on the screen. So you were, in a very real way, racing the electron beam. So if you like, by way of analogy, this would be like driving down the interstate and building the road in front of you as you drive. And these weren't even the only constraints. I mean, you had the slow input and outputs. You had very slow, very small media. So cassettes, in fact, were even used. They didn't get as much use in North America, but this was another form of media. And the developers themselves were quite constrained. So chances were, if you were a computer game developer for home computer, the machine you programmed on was exactly the one it would eventually run on. So there was nothing special for you as a programmer. And if you're a console developer, you weren't much better off. So this is an ADM3A, and this is a dumb terminal that was of exactly the kind that David Crane used to write this game, Pitfall. And you will notice there's only text on here, and there ain't a lot of it. very, very constrained environment. And in a lot of cases, developers actually wrote their own tools to do the programming. So it wasn't as though you were driving down the interstate and you were building the road in front of you. That's what you aspired to do. First, you had to invent wheel technology to get there. And the amazing thing is that they would do this in, at times, insane time constraints. So this is perhaps the most famous example. E.T. was pumped out in between 5 to 6 weeks. But that was eclipsed by this one, Chase the Chuck Wagon. The developer created this in a weekend. And you could argue that, well, these are crap games. Okay, it's hard to dispute. But on the other hand, if you consider the whole, the context and all these constraints, really it's amazing they worked at all. So this sort of sets the stage, really. This is an early version of Tetris. The lag, oh my God. So Aycokc wrote about the need for having more media archaeologists who would find all these little treasures. And what would a retro game archaeologist look like? What is retro game archaeology? Well, I would describe it in terms of the 3 T's. So understanding the tools, the techniques, and the technology that these programmers use to create these old games, and taking these ideas and putting them into some sort of broader context. So this is not about saying, well, E.T. did this. Okay, we're good. No, it's about saying, well, E.T. did this, and you know what? So did Raiders of the Lost Ark, so did Congo Bongo. And you never think, as a grad student, you're going to be standing in front of a room full of people talking about Congo Bongo, but there you have it. And then saying, okay, well, this thing that they were doing, this is actually what's referred to as bank switching, which belongs to a broader category, which is memory management. And then bringing it forward in time and saying, well, you know what? All these techniques, they're still used. They still have places in the world. Maybe not in games anymore, but they still have applications. And this is part of the justification for why you might want to spend time on this. So why would you do this retro game archaeology? Well, programmers, so computer science students, computer engineering students, they don't necessarily learn these things anymore because we don't have the same kind of constraints on our systems. And if I were in the history department, I might make this argument that history is important, perhaps with a pipe on my mouth leaning on the mantle. Okay, it turns out I don't actually know what they do in the history department, but this is my imaginary scenario. So I don't disagree with that. I do think history is important, but as a computer scientist, I'm a fairly pragmatic person, and what I'm more interested in is the fact that history is cyclic. And all these techniques that we discarded tend to come back and haunt us over a period of decades. So once upon a time, you would say, well, we have all these constrained systems, we have to deal with low memory. And then all of a sudden we got to the point where we had more memory and you didn't have to worry about that. And then someone came along and said, hey, we've got this idea for a cell phone that fits in your hand. Oh, by the way, it doesn't have much memory. And so now we have these smartphones which have lots of memory, and you don't need this anymore. But now we have sensor networks and embedded systems and the Internet of Things. And guess what? They all have the same constraints again. And I am still amazed that I was able to find that picture. The Internet is wonderful. Rabbit riding bicycle. So there's perhaps a bigger imperative, and that is, why would we be interested in doing it now? So for me, coming from Canada, we actually got some changes to our copyright law relatively recently. So down here you've had the principle of fair use for a while. And in Canada, we have fair dealing, which is almost but not quite the same thing and tended to be a lot more restricted. So our law changed, so now we have very clear exemptions for education and research, which is good, because I don't like prison. And the Internet Archive has actually done a spectacular job of not only archiving this material, but bringing it to life in people's browsers. So if you have not gone to the Internet Archive and played some of these old games in your browser, go do it. You will lose like 3 weeks of productivity, but go do it. It's cool. But I do want to make a distinction here, and that is what retrogame archaeology is not. So remember, what I'm interested in is the implementation of these games. And so it's not about playing games, which I remind my department head of very frequently. It's not about playing games. I'm not a game historian, so I'm not interested in necessarily finding the first or the best or the most influential. And in fact, some of these implementation examples, when you do find them, they're quite rare. They can be in some very, very obscure games. But you have to come to terms with that. You can't get upset about it, because it's like you found this unicorn, and then the unicorn pukes on your shoes. It's a unicorn. How many of these are you going to find in your life? Unicorns aside. The more sobering reason to consider doing this now is that, not to put too fine a point on it, the people who created these are not young anymore. And there's been several times just in the span of the last few years when I've been researching this that I will be trying to track someone down and they passed away. And in some cases, literally taking knowledge to the grave with them that we can't get back. So let me lead you through the process of this now. So you've decided to become a retrogame archaeologist. You have your bullwhip and your sidearm and your pith helmet, because it's fun to say pith helmet. Try it sometime. So the first step to this is choosing a subject of study. And there's a bunch of different ways you can approach this. First one, kind of a traditional academic research methodology, which is to say Google. And you can use this for some good lead generation, because there's lots and lots of people who have devoted insane amounts of time to studying their favorite games. So as an example, I want an example of a data compression technique called run length encoding. So I popped this into Google with some additional search terms, and after a couple of attempts, I found this blog I'd never seen or heard of before, and it said, yeah, I think this game, Spook House, uses run length encoding. So I'm done. Not quite. So there's this guy in the 80s who was fond of saying trust but verify. And as a researcher, you're always interested in primary sources. And for retro games, the primary source is the game code. If you don't see it in the game code, it doesn't exist. So I don't care that this blogger thinks that this is the case. Unless I have seen it, it doesn't exist. So you always have to go verify this stuff. Other times, you have a vague tip or a hunch that something happens, and so what I've done on a couple of occasions is actually set up an emulator to jump up and down and flag me if a certain set of conditions comes true. And then I just start playing one game after the other until all these red flags start flipping. So here's one example. I was looking for a particular type of copy protection on the Atari 400 and 800, which I figured had to be there someplace, but I didn't know which game would have it. And so I set up my emulator, started playing a whole bunch of games, and then lo and behold, I had a short list, dug into the code, and actually found one that was perfectly suited for what I was looking at. And sort of related to that, these hunches. So oftentimes, and there's actually 2 magazines, believe it or not, devoted to retro gaming. But they'll have these interviews with these old game programmers, and midway through, they'll be talking about something, and then someone will have like one sentence or a phrase, and it's like, that's the example I need. Are we done? No. Because, I can't remember what I had for dinner last night. Memories fade over time. And I do apologize because I put together this slide and then realized how wildly inappropriate it was to have Reagan beside the phrase memories fade. So sorry about that. But yeah, again, if you can't verify it in the game code, it ain't there. Okay, and the final method is just sort of more curiosity-driven questions like you would have in traditional research. So for me, there's the Atari 2600 version of Pitfall, and as you saw earlier, I picked up in a television. I was playing the television version. I was thinking, this looks a lot like the 2600 version. No, this looks a lot like the 2600 version. Is it actually using the same methods to actually generate the jungle? And down here, this is Yar's Revenge and Laser Gates. You'll notice the pretty colors here and here, and I was thinking, wonder if it's using the same technique to create these colors. And then finally, I was playing Super Mario on the NES, and thought all of a sudden, geez, I wonder how they store the data for these levels. And there went Christmas, actually. The answer is yes, yes, and it's complicated, if you're wondering. Okay, so you've chosen something to study, and the next problem is actually acquiring this. So finding the image. Usually what it comes down to is an iffy-looking website, and all I have to say is God bless the Russians, because they keep so much stuff around for us. If you're really, really lucky, you might find source code, but that's pretty rare. Sometimes you can actually still acquire these in a form from which you can study it, but yeah, by and large, dodgy websites. And then you have to try and run this. So sometimes it's just not possible. It's for some very obscure hardware, or the emulator doesn't quite work the way it's supposed to. And in any case, real hardware, you don't want real hardware. Real hardware is not your friend for doing this sort of work. What you really want is you want an omniscient view of everything. What's your friend? Emulators. Emulators are your friend. And there are some really, really good ones. This is one called Stella for the Atari 2600, and it gives you painfully detailed information about everything that's happening in that little machine. Now, the flip side to this is that emulators are so not your friend. Emulators suck in so many ways. Currently, I believe I have 4 or 5 Apple II emulators installed, because they all do slightly different things in slightly different ways, and I've had to use all of them in one case or another. And the tools they do provide you are not really set up to do this work. So in some cases, I actually need to modify the emulators or rip out their data to do work. And let me show you an example of what that might look like. So the TI-99 4A had this game called Parsec, and it had a graphics chip for which the programming interface to it was 2 memory locations. And so if you wanted to see what was going on inside a game in this graphics chip, it would be like the equivalent of trying to figure out how the furniture in a house is arranged by looking through the mail slot. Really hard. And so what I did is I had the emulator dump out all this information about what was flowing back and forth, and then created this visualization. So here, this is a reconstruction of what's happening in the game. And what you're seeing down here is all the memory in the graphics chip. This is one of the advantages. I mean, these things are small, so you actually have a shot at visualizing everything all at once. And if you're wondering how big this actually is, it was fairly big. We have a visualization studio on campus, and so I would actually run this inside there to see what was going on. But it's a bit hard to tell because of the glare, but each one of these is actually showing me the individual contents of every single memory location, so I could actually watch memory move around from one place to another inside this chip. And the scary part, the real work hasn't even started. So now we've decided on something to study, we've acquired it, we set it up to run. Now comes the analysis. So generally what I do is I don't try and figure out all the game code because there's really diminishing returns. There's a lot of game code which is very similar, which is very uninteresting. And so if I go into a game, I'm looking for something very specific. And you can actually look at this in a couple of different ways. So one way is a static approach where you're just looking at the code and you're not running it. And sometimes if you can't run it for one reason or another, this is your only option. Or dynamic analysis, which is where you're running the code and trying to figure it out. And if you like, this is like trying to solve a jigsaw puzzle where all the pieces may get up and move around on you at any point in time. It's really very exciting. It's like Sudoku of death. And the platform really plays a major role in this. So all of these machines, in effect, very many more, use a processor in it or variant thereof called the 6502. But yet if you looked at the game code for the exact same game which ran on several of these, it'll look wildly different because the graphics are done differently on each one and the sound is done differently and the I/O is done differently. So it's really a combination of the processor and the platform together that you need to figure out to understand what the code is doing. And then there's the data. So there's code, there's data. And data is oftentimes what makes the game. So what makes the screen look the way it does, what lays out the level. So you need to find it, which is not always an easy task. But then you need to figure out how the code makes sense of this. And sometimes it just pops out at you if you ask the right question. So, you see the pattern here? I didn't, to be honest, until I asked the right question. So this is the data from the first level of Load Runner. And if you ask the right question, then all of a sudden all the platforms pop out at you. In other cases, so this one's a bit trickier. This is the data for a game called Mystery House from 1980. And I was actually staring at this for quite some time thinking, oh, geez, I'm going to have to analyze the code to figure this out. And then I thought, well, how would I write the code? Well, I'd probably be lazy and do this and that. And yeah, sure enough, those are the right questions to ask. And all of a sudden, the structure of this popped out at me. And you aren't even working in a vacuum. You can actually take a scientific approach and test your hypotheses. So if you say, well, I think the jungle in Pitfall is laid out in a certain way, then what you can do is you can actually run this in the emulator. And you can say, well, all right, we're stopping the game, popping this into the debugger, changing a few values. Yep, jungle looks different now in the way I predicted. But for some games, this doesn't quite work. And so for other games which are more complicated and you can't do this hypothesis testing so easily, I will actually inject new content into old games right on top of the old stuff. So this is actually a text adventure game which I've convinced to compute prime numbers for me because I was trying to figure out how its virtual machine ran. And I would like to show you a version of the first Super Mario level that you had never seen before. I should point out that I'm not a level designer either. So what this was a, that's very disconcerting when you're standing by the screen and it's moving with you. What this was a test to help me figure out how all the elements in game levels were encoded. And I cleverly forgot to put the flag at the end, so this would actually go on forever. So you can inject into old games. Whoops. You can also create new old games. So some of these things have reusable engines. And so what I've done for some of these is created my own games so that I understand the languages that they were using, the expressivity, and also how these would compare on different platforms. So I've created a very, very lousy adventure game in many, many platforms now, specifically to get a sense of this. So I call it the telephone booth game, and you're in a telephone booth. Actually, that's pretty much it. You're in a telephone booth, there's a phone. But yeah, you can see some of these, it's actually quite verbose to actually get yourself to the point where you can describe that. Other game systems, it's actually a couple of lines and you're there. So you can get a good feel for how some of these things worked. And then there's some rather tough cases, and I showed you one with the parsec and the visualization wall thing happening. So for some of these, it's actually helpful to visualize the algorithms that are being used to make sense of what's happening inside the game. And this is from a game called The Seventh Guest. It was one of the first CD-ROM games, and these are running on very, very slow devices, very slow CD-ROMs, and so there's obviously some data compression happening, and I wanted to find out what it looked like. So this is a visualization of what's happening, and I actually thought it would be noisy, and then when one of these images popped out, I was like, wow. You can actually see the bad acting that they were doing in the game. So each of the red squares correspond to a video frame where it changed in that one frame. And the white is showing you where it changed overall during that scene. And the green arrows are, well, they're a superhero, but they're also, in this case, basically just positioning each one of these blocks on the screen. And this game literally had thousands of these clips embedded in it. It was a huge, huge undertaking. Should I go back to videos here? So this is another one, and they don't have to be pretty. What this is just showing me is how the algorithm's running. So this is for a dungeon crawler game called Beneath Apple Manor. I was trying to figure out how its algorithm was working for laying out the corridors between rooms. So what this is doing is it's showing me a textual rendition of everything that's happening in this game. And then if you get bored, it actually kind of looks like modern art if you just show it as colors. But so the final thing you might do is reconstructions, where you think you know how everything works, and the big test is, can I actually reconstruct from the original data everything that happened? Doesn't have to be pretty. So this is the first level of Lode Runner, which I reconstructed. This is what that mystery house data turns out to be. And if you're not familiar with the game, yes, it did look this bad. This is a dead-on match. Now, this is another one called The Hobbit, and this is one of Scott Adams' games. This is the congratulations screen when you complete the game. Incidentally, this is far easier than actually completing the game itself, just seeing what it looks like at the end. So obviously there's lots of work here in terms of building your own tools. So there's lots of stuff available, but I've actually had to write lots of my own code to do the visualizations, the reconstructions, just to give you a sense of this. So sometimes when you get source code, it is, how shall I say, not as helpful as you think it might be. So the source code to this famed game from the mid-'80s, Elite, does exist. And it is complete rubbish to try and make sense of. So there's no way that I could actually go through and try and make any sense of this. And so what I did is I wrote a tool called a Pretty Printer, which basically broke this all apart and reformatted it for me. And if you don't speak assembly code, you're just going to have to take my word for it that this is, in fact, much more readable and understandable. Retrogame Archeology is actually very, very technical work. But there's lots of really interesting stuff yet to find. And not only are, are the people around that you can still ask about this, but increasingly there's been more and more people who have found old source code for their games and who are making it available. And so there's an increasing amount of artifacts to actually go through and study and see how programmers worked back then. And the cool part for me, especially in terms of teaching my own computer science students, is all this stuff that was done back then still has relevance. Now, maybe it's not all in games anymore, but there's relevance in lots of fields. So data compression is still used. Computer security actually touches on a lot of these things, which is where my own interest in this started off. So there's lots of cool stuff to find, and this is the time to do it. Thank you very much.